Number 41 right here is asking you to complete the square and then find the maximum or the minimum. So the goal here really is to use completing the square to get this quadratic function from standard form into vertex form. Now, the two things you usually want to look for in order to do completing the square would be first that a is equal to 1 and secondly that b is even. Well, you can look at this one right now and say, wow, you guys are being jerks, because neither one of those two things happens right here. A is -4, b is 3. So given the choice, I would never choose to do completing the square on this problem. I would try it by factoring first, then I would go right to the quadratic formula if the factoring did not work. But I'm going to try to follow their directions because it's like eating your vegetables. There's probably a reason they're asking us to do that. So the first thing you would do here, if you were forced to do completing the square, is to try to make a equal 1 by factoring out whatever number this is on the right-hand side. Kind of. Let me show you what I mean. I'm going to pull this -4 out in front and then start a set of parentheses. When we divide out the -4 right here, we're just going to get x squared. That part was easy. I'm also going to factor out the -4 from the second term. And if you're sitting here thinking, wait a minute, you can't divide a -4 out from 3, well, sure you can. You just can't do it evenly, and that's okay. Welcome to higher level math, guys. We're going to take this coefficient, which is 3, and divide out this -4, which we're factoring out. And what's 3 divided by -4? -3/4. Thank you, fractions. So the x still goes there, and that's where we're at so far. Now, what we are going to do that's a little odd is I'm not going to factor the -4 out from the 8, even though I know that would have worked out really, really nicely. So I'm going to just leave some room, end this set of parentheses, and then just put the +8 at the end of all that. Okay, that's where we're at right now. Now, the point of completing the square is to create a perfect square trinomial right here, and that's what we're going to do now. So the way we do that is we take b, we cut it in half, we square it, and we add it here, and then we have to balance out that new number that we've added. So this gets weird, guys. We need to take -3/4 and take half of that. So you could either divide by 2, or the better idea is to multiply by 1/2, and you're going to end up with a -3/8. Guys, I'm kind of hoping you'd realize that if you want to take half of a fraction, you can either cut the numerator in half, bad idea because this is odd, but technically 1.5/4 is half of 3/4. The other thing you can do is double your denominator, and that's where we get the 3/8 from. Anyway, so you take half of b, which we now have right there. You're going to square that, and the negative will go away now. That's going to become 9/64, and you're going to add that right here. So plus a 9/64, and now we're in business. Now we've created a perfect square trinomial inside those parentheses, which is the whole point of completing the square. However, I can't just add 9/64 because I feel like it without balancing that out in the equation. Now, the first thing we need to realize is this, guys, even though it looks like we added 9/64, we didn't, because this -4 gets distributed into the parentheses here. So I need to multiply, let me do this at the bottom again, -4 times 9/64. Well, if I divide a 4 out, that's a 1 and a 16, and I end up with -9/16. So it looks like I added 9/64 here, but because of this coefficient of -4, what that really means I did was I subtracted 9/16 on the right side. That's what I need to balance it out. Now, what we normally do with completing the square is whatever you add to the right, you also add to the left. Or, said a different way, whatever you subtract from the right, you also subtract from the left. So I'd make that a y minus 9/16. However, that's what I would do if I were solving a quadratic equation. But this is a quadratic function that I'm trying to get into vertex form, which really means I want to leave the y alone on the left-hand side. So rather than subtracting this 9/16 from the left, what I'm going to do instead, To balance out the subtraction of 9/16 right here is I'm now going to add 9/16 at the end of the right. So it's kind of like I added a number and then subtracted the number, both on the same side. And the important thing there is that the net change to the right side of this equation is 0. And hopefully that satisfies your mathematical sensitivities right there. You can look at that and say, okay, he did one thing, but then he totally undid it, so everything remains in balance. So where are we now? Y is equal to, we still have the -4 out in front, and now we factor the perfect square trinomial. A perfect square trinomial factors into a single binomial squared. And what is that binomial? You take the square root of this term, which is just plain x, the square root of this term, which is 3/8, and whatever this sign is right here, you bring it straight down, whether it was a plus or a minus, and in this case, it's a minus. So we have that, and then at the end here, we're going to add to that, I'm going to simplify 8 plus 9/16. And let's think about that. Let's see, 8 times 16, well, 8 times 8 is 64. We would double that to get 128 over 16, and when we add 128 over 16 and 9 over 16, that is going to get us 137, gee, this is fun, over 16. And guys, that's pretty horrific, but that is the original equation we were given, now put into vertex form. Now let's answer the rest of the question. And it says, let me read this properly here, guys, and find the minimum or maximum value of the quadratic function. Well, first of all, which one is it? Well, if you go back to the original standard form equation, that negative tells you that this parabola opens downward, which means that it has a maximum value. And where does the maximum value of a downward opening parabola occur? Right here at its vertex. So what we need is the y-coordinate of the vertex of this parabola. That's your k value, which comes right here at the end, guys. So the maximum value here, not pretty, is 137 over 16. So one of two things happened, guys, when this problem was being written by whomever it was who was writing it, making your textbook. Either they got a little bit sloppy and maybe didn't work the problem out, and it didn't work out as nicely as they thought that it would. That happens kind of a lot to me when I'm writing test questions. Or they really didn't care and decided it would be a good experience for you students to have to deal with something quite this nasty right here. So, well, one way or another, that's how we solve that one, and that's the answer to problem number 41.